Welcome, everybody. This is Pulumi and Kubernetes Better Together. My name is Josh. With me on chat support is my colleague Piers. And so he will be helping out with the chat and maybe hopping in on the mic to ask me if any pertinent questions. Okay, so today's agenda. First, I'm going to speak a little bit about the Pulumi platform. I'm going to tell you what it's all about. And then I'm going to go into all the things that you can do with Pulumi and Kubernetes. And then we're going to show you some demos of those things. And then we'll have extra time for Q&A at the end. So hopefully that sounds good to you. All right, so let's start with the Pulumi platform. Our tagline on this is automate, secure, and manage everything you run in the cloud. And I will show you how our platform helps you do that. So the platform itself is kind of made up of three products. The first is the one that you're most likely familiar with. That is Pulumi Infrastructure as Code. And Pulumi IAC allows you to manage resources in a declarative way using for any cloud using any programming language. And any cloud, of course, includes Kubernetes. Our second product is Pulumi ESC. ESC is a secrets broker or a secrets manager, you might call it. What it allows you to do is allows you to gather a lot of both secrets and configuration values. That's the S and the C, and group those things into something called an environment. And then you can use that environment and then use that to do things like either run Pulumi Infrastructure as Code programs or any command line command, including you can use it to manage kubeconfig files in a really, really convenient way. And I'm going to show you that later on. And then finally, we have Pulumi Insights. Pulumi Insights is our tool that will allow you to visualize and manage all of your resources in any cloud, regardless of whether those are managed by Pulumi Infrastructure as Code or not. And then you can take those resources and basically find out anything you need to find out about the stuff that you're running in the cloud. So the Pulumi Insights is there to answer the question, what do I have running in the cloud? And then between all three of these products, we have these sort of cross-cutting capabilities. The first is Pulumi CrossGuard. That is our policy and compliance engine. So you can use that, for example, to run policies against any resources, especially if they're managed by Pulumi Infrastructure as Code. Second, we have Pulumi deployments, which is you can do a lot of stuff with. The primary use cases for that are like CI/CD, so it's like a managed CI/CD tool. But then we also have a lot of features involving like webhooks that can help automate all of those platform engineering workflows that you have. And then finally, we have Pulumi Copilot, which is our AI component. And Pulumi Copilot is built into both Pulumi Cloud, and then there's also like a free website that you can use to help generate Pulumi IAC programs. And so that's Pulumi Copilot. So that is the entire platform. If you have any questions on that, please hop over to the Q&A tab, and we will get to your questions as soon as we can. Okay, so Pulumi IAC is the first product. The fundamental feature of the product, it combines two things that makes it unique in the infrastructure as code space. One, it allows you to use general purpose languages, and the list of languages we support are in the upper left-hand corner. So that's Node, Python, .NET, Go, JVM, and then we also have support for YAML, which is useful for certain edge cases. Second, and so like, why would you want to use general purpose languages? Well, there's a couple reasons. First, you are able to use just the native syntax of that language, right? So if you want to use a for loop, you just write a for loop. Doing those things in YAML or HCL is much, much more painful. If you want to take a slice of an array, you just use whatever the natural syntax is in your language of choice to take a slice of an array, as opposed to other DSLs like YAML or HCL, where you're going to have to learn special syntax to do those things. All right, so that's the first reason. The second reason is that your tooling is going to just work, right? So Pulumi programs are just regular old fill in the blank here programs. If you're using Node, they're just regular old TypeScript programs, for example. And so you're going to be able to use all of your tooling, your IDEs, whether you're using Visual Studio Code or Vim or, God forbid, Emacs. You can use those things. You don't need any special plugins. You just get the usual code completion and sort of syntax highlighting that you are used to. So that's the second reason. The third reason is that you're able to leverage the ecosystems of the language that you're using. So again, if I'm taking the example of Node, right, you are able to consume an npm package and use that in your Pulumi program to drive the infrastructure. You can also, in addition to consuming packages, also share Pulumi code, and they're just regular old, for example, npm packages, right? They're just regular old packages in the languages that you are using. So that covers why any language is useful. And then it's both any language and any cloud. So Pulumi has a large ecosystem of providers. We have over 170 as I am delivering this workshop. They include, of course, all of the hyperscalers, so AWS, Azure, Google Cloud. Then we also have our Kubernetes provider that I'm going to talk about a little bit later. We also support OCI, and then we also, in addition to that, support a long list of SaaS providers and smaller clouds. So Datadog, New Relic, GitHub, GitLab, whatever SaaS products, or if you're using a smaller cloud like Linode, for example, we support all of those things. So you can manage and orchestrate resources between all of these things in a single Pulumi program. So just to give you an example of like how you might use this, you might want to spin up an EKS cluster using the AWS provider. Then you might want to deploy something onto that cluster using the Kubernetes provider. And you can do this all in a single Pulumi program. You actually cannot do this in Terraform. And then you might want to say, after all of that spun up, update some you might want to update your DNS, for example, in your public DNS in Cloudflare, something like that. And so you can orchestrate all of these resources and all of the dependencies between them using a single tool, and that's Pulumi. Okay, so our second product in the platform is Pulumi ESC, which, as I mentioned, stands for Environments, Secrets, and Config. This will be a lot more. The value of it should be a lot more apparent once I actually demonstrate it, which I'm going to do later on. So I'm not going to spend too much time here. But essentially, what it allows you to do is you define an environment in YAML. An environment consists of secrets and config values. Those things can come from a variety of sources. So you can store them directly in Pulumi Cloud. You can use the secrets providers of all the major clouds. In addition to the secrets, you can also get OIDC creds from any of the three major clouds. And then you can also pull from Vault, and you can pull from 1Password. And then what you do is you're going to define your environment, and then you're going to use your environment to do something. And that something is usually you're going to either run a Pulumi infrastructure as code program or any CLI program. And what I'm going to demonstrate later on is how you can use this with kubeconfig files to run kubectl commands. I'm actually going to be using K9s because I think it's amazing. But that's the basic idea. So that's Pulumi ESC. And finally, we have a new version of Pulumi Insights. It's going to be coming out soon. It will work over any infrastructure. It will work even if for resources that are not controlled by Pulumi IAC. So this is very, very exciting. And so what you can do is you can, for example, scan your AWS account, get all of the stuff that's running in that account, and then you can make charts and graphs and visualize stuff. And there's a lot of more exciting features to come. For example, CrossGuard that will allow you to write policy for resources that are not under Pulumi control, so that you can help get your resources under compliance. It doesn't matter what IAC tool you're using to manage those things, even if you're not using any IAC tool at all. So this is really exciting stuff. I'm really looking forward to this. There is a wait list for this you can sign up for within Pulumi Cloud. So if you are interested, please check that out. And then coming back to the cross-cutting thing. So we have 3 products, and then we have 3 like cross-cutting elements, three cross-cutting layers of the cake. Pulumi CrossGuard is our policy as code tool. It essentially allows you to write. It will allow you to write policies against resources, and then it will essentially tell you whether those things are in compliance or not. And then you can determine the severity of the violation, whether it's a warning essentially or an error. Pulumi deployments, again, this is our built-in CI/CD, and it also incorporates a lot of integrations with different webhooks. So, for example, you might want to run drift detection on a schedule for your Pulumi program, you can do that using Pulumi deployments. And then, for example, if drift is detected, you could, for example, send a notification to Slack that would alert your platform team, like, hey, there's drift in our in one of our VPC subnets or something like that. And then you can resolve that drift. So that's Pulumi deployments. And finally, Pulumi Copilot, it is generative AI. You can do a lot of stuff with it, but the two main things where it comes in is you have a built-in prompt in Pulumi Cloud that you can ask about your different resources. So you can, for example, say like, hey, show me RDS clusters that are running an outdated version of MySQL. And it would be able to give you a list of those things. And you can also use it to generate Pulumi infrastructure as code programs. And the link to that, Pierce, if you could put that in there, is pulumi.com/AI. So you can give this a spin even if you don't even have a Pulumi Cloud account, although I would definitely recommend that you check it out within Pulumi Cloud. Okay, so thank you for your attention for that. Let's get into the ways that Pulumi and Kubernetes can work together. Okay, so the first thing is the Pulumi Kubernetes provider. A provider in Pulumi is what allows you to manage resources in a given cloud. So, for example, we have an AWS provider, we have an Azure provider, and then we also have a Pulumi Kubernetes provider. In the world of Pulumi providers, there are two types of providers. There are bridged providers. Bridge providers take a Terraform provider as an underlying dependency. However, it's important to understand that we do not use any of the Terraform core code, and therefore we are not affected by the license changes that HashiCorp put forth recently with the change to the business open source license. So the Pulumi Kubernetes provider is a native provider. We created it because there are some problems with the Terraform Kubernetes provider. That was something I heard in the field long before I ever even knew that Pulumi existed. And so the way a native provider works in Pulumi is that we take the API spec directly, and then we use that API spec to generate the CRUD-L methods: create, retrieve, update, delete, list. And so you can create a native provider in Pulumi against anything that has an API spec, whether it's Open API or some other spec. And essentially, that is what's going to drive the schema that we maintain in a Pulumi provider. So the good news about this is that, like, when you're writing Pulumi programs and using the Kubernetes provider, the shape of like the options for, let's say, this like a namespace, it's going to look exactly like the YAML that you would write, except that it's going to be strongly typed. And that's gonna make this a lot easier for you to write stuff. And I'll show you this. I'm going to show you my IDE in a moment. I'm actually going to show you how to do these things. It also works with Helm charts. So in this little clip, and I'm also going to show this later, there is a Helm chart resource. You can do server-side apply. So in addition to like the config map resource, there's also a config map patch resource. And you should be able to do everything that you can do in Kubernetes YAML using the Kubernetes provider. So like all of those resources there, whether it's service, deployment, config map, et cetera, et cetera. And then it's also compatible with existing YAML manifests. So I'm going to show you how to coexist with any pre-existing YAML manifest that you might have out there. And so that's going to be cool. So stick around for that. In addition to the Kubernetes provider, there is also a Pulumi EKS package. What this does is this will make the process of creating and managing EKS clusters much easier. We actually just came out within the last month or so, I think, with a new major version of the EKS provider, and I'm going to be showing that today. So what this does, again, it's going to make it much easier to manage your EKS clusters. There is also a tool if you have custom resource definitions. We have a free command line tool called CRD2 Pulumi. And so what that does is if you have a custom resource definition in YAML, you can run CRD to Pulumi at the command line, point it against it, and tell it what language you want the output to be in. And it will make strongly typed Pulumi resources for your custom resource definitions, which is like really going to make your Pulumi experience with Kubernetes really, really nice. And I'm also going to show that in a moment as well. And then finally, I think finally, maybe not finally, close to finally, we have a Pulumi Kubernetes operator. So if you want to run Pulumi programs in a GitOps style, what you do is we have a custom resource definition for a Pulumi stack. It essentially points at a flux source. And then if you run the operator in your Kubernetes cluster, we will ensure continuous delivery with that flux source. All right. So again, any questions, let me know. Yes. Okay. So I think this is the last thing. And then finally, and I'm going to show all the things that almost all things. I don't know if I'm going to show the operator today, but I'm going to show you all the stuff that we talked about here. So Pulumi ESC also has some really, really helpful features that let you manage kube config files. So with Pulumi ESC, you can store a kube config. You can use it with any CLI like kubectl. I'm going to be using K9s today. I'm a huge K9s fan. So I'll show you that. And then one of the other things you can do with Pulumi ESC is you can import other environments. So you can kind of combine different environments. So like, for example, if you wanted to connect to an ESC, or excuse me, if you want to connect to an EKS cluster, that's usually done with IAM authentication plus your kube config. So you can set up ESC to use OIDC credentials from AWS, and then you can import those and combine them with your kube config file. And then you get both of the things that you need in order to connect to a cluster. And that authentication is controlled by your Pulumi cloud identity. So that you don't need to manage like multiple identities in multiple places. And it's also on ESC, by the way, it's also compatible with the external secrets operator in K8s. Okay, so now it is demo time. But before I do that, let me take a look at the Q&A tab. Let's see if we have anything here. Give me 1 second. I'm going to read over these questions. So
we had some questions about EKS and how we can support private endpoints. The CNCF cluster API is interesting. I didn't know that existed. I don't think we support it today, but I'm sure it's something that we'll look at in the future if it kind of as it grows and gains support. Yeah, so some really interesting questions there.
Yeah, I'm actually really curious to learn more about the cluster API. I'm not aware of that. Is it what makes a does it allow clusters to spawn other clusters by any chance? Is that how it works? I like vaguely remember hearing about this.
Yeah, so it sounds like it's something that where you can define cross cloud clusters. So we're looking at kind of doing them across like Azure and Amazon. Just look at the list here: IBM Cloud, Hetzner, Nutanix, OCI, OpenStack. So you can it sounds like an abstraction over the top. Sounds like something we should build. To be fair,
sounds like something we might need to do another workshop on.
Yeah,
after we learn about that.
That sounds super interesting though.
So we do have this question. Can you deploy your own private cloud agents on-prem for Pulumi Cloud? So this is a great question. So this pertains to, I believe, Pulumi deployments, which is our managed CI/CD, and we actually do have support for this now. So you can run Pulumi. So using Pulumi deployments, you can manage your own agents, as you can with a lot of other CI/CD systems, and then you could do that on a virtual machine like an EC2 instance, but we now also support the ability to do that on Kubernetes. So you can have Pulumi deployments do its work on a cluster that you own. All right, so so there we have a lot of great questions here. Thank you so much, by the way, for everyone that's asked these questions. So we have one question: where is the link for the CRD deployment tool?
Just writing that in.
Yeah, I can back that up. It's right there.
Oh yeah. So we have a homebrew. You can install it using homebrew, or if you go to the releases page, you can download and run the binary.
Yeah, I did it via homebrew. Yeah.
Yeah.
All right.
If you're on Windows, this is a zip file.
Okay, so let's hop over the screen. By the way, all the demo code, if you go to it's in the Pulumi workshops repo, and then you just need to click on the Kate's Better Together link. So all the demo code that I'm showing is here. If you had any trouble with it whatsoever, please just submit an issue that will come to my attention, and I will do my best to get that resolved for you. Okay, so let's hop on over to Visual Studio Code. Let's take a look at some code. All right, so I have already run this Pulumi program. By the way, if you've never seen a Pulumi program, this is what one looks like. I'm using TypeScript today. Pulumi, again, supports a large list of languages, including Python, Go, .NET, Java. Each one, we try to make the experience of authoring a Pulumi program to be as idiomatic as possible in that language. And so hopefully the stuff translates for you if your particular favorite language is not TypeScript. So you'll notice here the first thing I'm doing is I'm importing some stuff. So we bring in the AWS provider. We bring in the Pulumi cloud provider because you can actually use Pulumi to make resources in Pulumi cloud. I'll show you what that is in just a second. And then we also bring in this AWS X library. So these are component resources for AWS. It basically, what I'm doing here is I'm creating a VPC. If you create a VPC using the AWS provider, that is literally just the VPC. But if you use the AWS X provider, then it's a VPC with subnets and route tables and all of that stuff. So it's kind of like our level 2 constructs for AWS. Likewise, that's also the type of bucket that the EKS package falls into. It is a component that actually comprises a lot of different resources. It's not just the EKS cluster. For example, you can see down here that I have the option to create no IDC provider. So it does that for you. And so it would create, for example, the IAM resources to create no IDC provider. Now, as I mentioned, the authoring experience, this is just a regular old TypeScript program. So I get autocomplete here, just as I would expect. If I do something invalid, it will point out that, hey, this has to be like a Boolean. So again, I get that authoring experience that I expect using standard tooling for my programming languages. So I'm going to take you through this program real quick. So this is, again, what creates an EKS cluster. I'm going to create a VPC. I'm going to deploy the EKS cluster into my VPC. I do have to use API mode authentication or API plus config map. If you don't use EKS and don't know what that is, consider yourself lucky. I am going to skip core DNS as an add-on just because that takes forever to do. And then I'm going to I'm also going to install the EBS CSI controller, which allows my EKS cluster to provision persistent volumes using EBS. This is not as easy, quite frankly, as I would like. And that's some feedback I brought back to the engineering team. So I would hope to see some improvements to make this a lot easier so you don't have to write all this stuff yourself. But you do have an example here. It works, and it is, I think, reasonably secure. So I'm going to, this also real quick shows you can create an ECR repository as well using one line of code. And then once I create my cluster, I install the add-on. I'm going to create a Pulumi ESC environment, and that environment is going to it's going to contain my EKS cluster's kube config, which is going to allow me to reuse that kube config wherever I want without having to move a file along between my machines. And so I am declaring that environment here. I'll also show you what that looks like in the Pulumi Cloud UI when it's time to use it. And then these two lines down here, these are called stack outputs. This is what allows us to view the values from outside of our Pulumi program. So you use stack outputs to either get a value from the command line or to get a value from another Pulumi program. All right. So, and this is a very common setup, right? We're probably going to have our cluster declared in one Pulumi program, and then we're going to want to use the kube config there to deploy a workload to that cluster. And so that's exactly what we have right here. So this is the workload-plain folder. So what I'm doing here, I mentioned that we have our stack output. And so the way that you get a value from one Pulumi program to another program is to use what's called a stack reference. All right, so all I have to do here is put in the name of the stack, the fully qualified name of the stack. And then I can grab the kube config from the EKS cluster that I created. That's the last file I showed you. And then we're going to create an instance of the Kubernetes provider. And then we're going to create an Nginx deployment and an Nginx service with a load balancer. And then we are going to export the host name of that service. All right, so I'm going to move to the right directory. This is workload-plain. All right, and then if I want to execute my Pulumi program, that command is Pulumi up. So when I run that, it's going to give me a preview of what it intends to do. And I have run this before on a different Kubernetes cluster. So this may or may not work because I've torn down the cluster since the last time I ran this. But I can get around this. All right, we're looking good so far. Hopefully the demo gods are with us. Oh, yes. So someone has actually replied in the chat, by the way, that yes, you define clusters using a kube manifest. So essentially it makes a cluster a Kubernetes resource itself. So if someone could answer me in the chat, if that is a CRD, then you could probably do that today using CRD to Pulumi. And if it's a part of the actual Kubernetes spec, then that would be a part of the Kubernetes provider. And if anyone can give me the kind.
So it's I was going to say, hey, it's not an official one. It's an x-kates.io namespace. So it's not there yet. It does have Helm charts, and you can probably do it. I'm guessing you could probably do it through the custom resource.
Yeah, so somewhere in there, right? I believe there has to be a custom resource definition. Yeah. And if that is the case, then you would be able to use CRD to Pulumi if you wanted to make them strongly typed and have them work exactly like the sort of built-in resources that you see here. All right, so now you can see that I have my ELB is spun up. So I can go Pulumi stack output URL, and I can copy that URL, and I can bring over my web browser, and then hopefully we have ourselves, and then Nginx is up and running. So that's not that interesting. It's okay. By the way, when I spun up my cluster, my EKS cluster, it did take a while, as you can see, 21 minutes, because that's kind of how EKS goes. This is Pulumi Cloud, by the way. So if you don't have a Pulumi Cloud account, you should definitely get one. It is free for individual use forever. We don't ask you for any credit card information. And so like if you're learning Pulumi, it's just going to make your life easier. Highly, highly recommend it. So within Pulumi Cloud, I can go into any one of my stacks. So again, this is the one where I created my EKS cluster. I can see the resources in my stack. Some of those resources have links to open them directly in the AWS console, which is really helpful. And you can see like all of these. You can see that for each update that I ran, Pulumi up, that I get git context information. So it tells me what branch I'm on and what revision I'm on. And if I did it a little bit differently, it would also tell me what repo. Oh no, I'm sorry. This is for Pulumi deployments. But it will, this should take me, yeah. Well, the branch is gone. That's why it's not there. But it would take me right to, so to let you know, for example, that uncommitted changes were there, which, may be something you want to take a look at. I can click into the details, by the way, of any given update, and it captures all of the command line output, which is really useful. So you can see here, all the resources that were created. If anything was deleted or changed, that would also be there in that output. Also, if you're using our policy as code, all the policy stuff is also captured in that command line output. So at a very basic level, Pulumi Cloud will give you a really nice UI so that you can tell who changed what and when and possibly why, which is really, really important if you're working in a collaborative fashion. Okay, so that is Pulumi Cloud. I'd like to come back to Visual Studio Code. Okay, so now we've seen, here's how you, if you want to write your own, if you want to start replacing YAML manifests and start writing that stuff in a, using a strongly typed language, this is how you would do it. So you use the Kubernetes provider and you use, for example, the K8s apps v1 deployment resource. Now, if you want to take this a step further, right, you can start to do things that would allow you to replace something like Helm, right? So you can set configuration values in Pulumi programs. That's like really important. I'll give you a quick demo of what that looks like. So I'm going to go Pulumi config set, and I might do something like image name. And I might set that to Nginx 1.27.2, right? So when I do this, it creates my stack configuration file because I haven't set any stack configuration yet. So that value comes in here. Now, if I wanted to go into my Pulumi program, I can grab that value and I can go const config equals new pulumi.config. And then go config, and then values can either be required or optional. If you want it to be required, you use require, and then the type. And if you want it to be optional, you can use get. So let's say if I wanted to make this required, I can go require, and then the name of the thing, image name. Image name, is that what I called it? Yes. I assign that to a variable. And then if I wanted to, I can now make this image, excuse me, parameterizable. Now, each Pulumi stack, you might have a dev stack, a QA stack, and a prod stack. That's like a very common way to arrange your stacks. Each stack has its own configuration file. And so now I'd be able to set the particular image that I'm deploying to each environment. So that's config. The other thing you can do with Pulumi that would allow you to potentially replace something like Helm is that, again, you're going to be able to use both config values and you can use loops and all that stuff. And you can kind of get rid of all of the, frankly, painful stuff that's part of writing a Helm chart. So hopefully that connects for you and that you check that out and that will be helpful for you. All right, so that is demonstrating the plain resources. Now, if we wanted to work with existing plain YAML manifests, so that example is here. So the key difference of our approach here is that we are using the config file resource. There is also, in addition to config file, there's config group. The primary difference is that config file takes a single file and config group will take a glob. So you can point it at a directory, and then I believe it will load those things in alphabetical order according to the glob that you specify. So here in the YAML, we have, again, this is almost exactly the same stuff that we specified in our plain workload. But this is how you would do this if you have existing YAML manifests and you want to slowly migrate to Pulumi. So you can use this. You can use this config file resource and use that to work with your existing resource, and then you can also mix and match this with sort of native Kubernetes resources in Pulumi. So you can, and then Pulumi will also behind the scenes be keeping track of all the dependencies between these things, and will make sure that things get done in the proper order. So if I want to, I can go over to this YAML directory, and then I can run Pulumi up.
Can I just jump in while that's running? So this is why I love Pulumi for Kubernetes deployments over something like YAML. With YAML, you kind of need to know the order of that you're deploying the manifests in, especially if you're just using kubectl. Not quite sure what Argo does, but with Pulumi, because we can pull out those dependencies and we can actually draw a dependency graph internally, we know what order we need to deploy things, and it means that you're not kind of waiting around. A service doesn't get deployed before the deployment. It's all kind of done in that order, and yeah, it's a great improvement.
And I see that mistake here. I think it's not waiting for the service to be ready. So I'm just going to pull me up. Why? Oops. Yeah, there's a little bit of work I have to do on this to get it to work, spinning it out from scratch because it's not waiting for the service to complete deploying.
Yeah, so that's what I was talking about. See, if these have been written out in actual pure Pulumi, in TypeScript or so forth, rather than using the YAML, or use depends on, actually, that would work. That means you get the right order in the deployments.
Yeah, so we are going to now. So since I wasn't able to grab that URL of that service programmatically, we're going to grab it using canines. So real quick, I'm going to head back to Pulumi Cloud. Now, you remember when we set up our EKS cluster, part of that was creating a Pulumi environment. So in Pulumi Cloud, I can head on over to environments, go down to this this project. Projects are just groups of Pulumi environments. Go to EKS cluster. And here you can see this is my environment definition. I did this all programmatically, but there's also an editor within Pulumi Cloud where you can create this yourself if you want to. And so what I'm doing is I'm taking the stack output, which is my my kube config from my EKS cluster, and then I'm saying I want to output this to a temporary file called kube config. And then what I can do now is I can run the Pulumi env open command or the Pulumi env run command. And what it will do is it will take this value, write a temporary kube config file locally, and I can use that to then run commands from that. I could also take that kube config if I wanted to and pass it off to a Pulumi program. And the syntax for that is slightly different. And then all of that is covered by the syntax example. And then there's also a spot in the docs, which I'll show you real quick. If you go down into Pulumi ESC and then integrations and then Kubernetes, we talk about both the external secret operator and then the example that I'm showing here. This is exactly like basically where I got it from. So you can either pull your kube config from a Pulumi stack output, or you can define it directly in line. And that's what we have on the screen right now. And then you can, again, so Pulumi ESC, by the way, it has its own CLI called ESC, but it also has exactly the same functionality in the Pulumi CLI that is used for Pulumi infrastructure as code. Hopefully that's clear. If anyone has any questions about that, I can maybe explain it.
Josh, there's been a question in the Q&A about can you make the Kubernetes provider not load automatically the default kubectl, so force it to declare the provider. So
great question. So yes, that is exactly what I'm doing here. So there's two ways. So there's implicit providers and there's explicit providers. This is an explicit provider right here. So I'm creating a new provider and I'm telling it what kube config to use. If I did not, and then also later down here, I am setting an option on my config file to say, hey, do this using the Kubernetes provider that I explicitly created, not the default. If I did not do this, it would use my system kube config. There are other ways to accomplish this as well, by the way. But basically, like you typically want to use explicit providers. Like one common scenario for that is that you might want to do that for if you want to set up like something in 2 AWS regions, for example. The AWS provider is typically bound to a region. So let's say you want to do US East 1 and US West 2, right? What you would do is you would create 2 AWS providers and explicitly specify the region in each one. And maybe the account as well if you're doing stuff in different accounts. And then you can provision resources and say, this resource belongs to this provider. So this is also, by the way, if you wanted to do a multi-cluster deployment at the same time, you can make, let's say you have 2 K8s clusters. One is like your primary and one's your secondary, right? then you could then go through your resources in a loop and deploy them to both clusters. So that's how you would do that. And that's made much easier by the fact that Pulumi uses general purpose languages. Okay, so back to our environment. So again, you can put a kubeconfig file in a Pulumi ESC config, and then you can use that to do Kubernetes stuff from the command line. So I have that command here. So what this command says is Pulumi env run, and then the name of my environment, which is, there's like a fully qualified path. It's basically Pulumi org, then the project, and then the name of the environment. And then what I'm saying here is I want to use this environment to run the K9s command. And K9s, by the way, is a text UI that allows you to do all the things that kubectl can do, but in a more interactive fashion. So I'm going to do that. You can see kubectl starting up. Excuse me, K9s starting up. And by the way, K9s is open source, so it's I believe it's k9cli.io, something like that. So what I'm going to do is I'm going to go to services. Here's a list of all my services. Here is my Nginx service YAML. That's the service I deployed that I had a little trouble getting the ingress for. So I'm just going to copy that here. Head over to my browser. Make sure it uses port 80. And we can see Nginx is now up and running. And this is again is the version using the YAML manifests. Okay, so that covers that use case. Finally, oh, you know what? Before we go to Helm, I'll show you. So this is by the way what it looks like when you use CRD to Pulumi. All this stuff in this CRDs folder is automatically generated. This is my CRD. So this is the cron tab. This is the sample CRD that they give on the Kubernetes site. And so what I did was I took this YAML file, I ran a CRD to Pulumi command, which is somewhere in my history. So I ran this command, and then Pulumi CRD to Pulumi automatically generated all this code in my CRDs folder. And then what I can do is within my Pulumi program, I can import it, and then I can new up a cron tab. And as you can see here, it's now strongly typed. Because the cron spec and the image. So these are parts that are defined in the CRD itself. So this will get you from a YAML CRD definition and make it totally usable within Pulumi. So you can use this for your own CRDs. So that's CRD to Pulumi. And final example here, I'm going to show you how to do a Helm chart in Pulumi. So again, I'm using a stack reference. I am grabbing a stack reference to my EKS cluster that I created earlier. I'm grabbing my kube config. And then I'm newing up kates.helm.v4.chart. I'm pointing that at the OCI URI for the WordPress chart. I also have to give it a little bit of extra config for EKS because it creates the storage class GP2. So I have to tell it to use that storage class. Otherwise, the persistent stuff would not provision. I'm going to switch to that directory. I'm going to run Pulumi up. And by the way, before when Pulumi up runs, it's going to give me a preview of what it intends to do. And so you can see here, it actually does expand all of the resources that are a part of the Helm chart. So you can see, you get a pretty clear idea of what it's going to do. I'm going to say yes. I'm going to give a little itty bitty caveat that this should work. Well, there's a chance it might not, and that is because, again, I tore down the cluster that this was originally running on, and I don't think I cleaned everything up. Yes, so that's what those creating fail are from. That is because I did not clean stuff up. But everything else should run, and hopefully, once it spins up, it should. I say should. Everything should provision, but I did have to do some manual cleanup because of a mistake that I made. But for you, this should work very smoothly. Yes, Piers.
So great question from Eves here. are the same tools usable to target a local kind/minikube cluster? I've already answered this in the Q&A, but I just want to say, make sure everyone knows this. These Kubernetes providers, they will work against anything that has a standard Kubernetes API attached to it.
Yeah.
So kind, minikube. I've run this on like containers on my local. I have demos that I run at things like KubeCon or other conferences where there's terrible Wi-Fi, but still want to show some of this stuff off. So yes, all the Kubernetes provider will 100% work as long as what you're running has a valid API.
Yeah, the Kubernetes provider itself is totally decoupled from the platform on which you are running Kubernetes, if that makes sense. So this failed again. This is probably because of my poor cleanup from something I was doing before. But let's hop on over and see if we actually got the front end here. Well, there is a URI for it. So if I go in and describe it, we're living on the edge here, folks. This may or may not work. Whoops. Firefox. Oh, it did work. All right, great. Yes. So again, those failures that you saw, please excuse those. Again, that is because I did not properly clean things up. So that stuff did not get deleted. I might even be able to. Yeah. So we did work. We did get everything spun up. You can see if we go into like our PVCs, those got bound because we have the EBS CSI driver. So that is all of the demos. Let's head over to Question Town real quick and see if there's anything we might want to throw up on the screen. If you have any more questions, by the way, please ask in the Q&A tab. But I'm not seeing any right now. Just scrolling through. By the way, thank you to everyone for your excellent participation in this workshop. I really appreciate it. Really, it makes it a lot more fun for me to deliver when there's an audience that's asking such great questions. Here's a great question. So does Pulumi have higher level constructs that are official or community managed, like an AWS CDK? For example, a ready-made setup of static web server on K8s with an index set of resources. So we do have some secondary level packages. They are more around AWS and EKS itself than it is around Kubernetes. But we do have examples, but it would be kind of hard to make, for example, a static web server on K8s. Actually, I would even question why you would want to run a static web server on Kubernetes, because you could just use an S3 bucket or something like that for that purpose. But yeah, so like we do have higher level constructs. They are officially managed by and large. You can see these, by the way. Let me go back to my screen. I'll show you where you can find the stuff that we have. So you can go to pulumi.com/registry. This, by the way, is where the API docs are. So so for example, if you want to look at our packages and like you search for EKS, that's where you go to the EKS cluster. You can click into it. And then here's where you can see, for example, all the options for creating an EKS cluster. Now, let's go back to here, and then we'll also show the. Oh, sorry, I have forgot to close the thing. Sorry, everybody. I'll do that one more time. All right, so you go to pulumi.com/registry. I can filter by package name. I can go EKS. That'll show me the EKS package. I can click into it, look at the cluster resource. And it gives me an example, and then it also gives me all the inputs and outputs to the EKS cluster. I can also go in here and look at the Kubernetes provider. And so like I can look up, let's say, deployment, and get all the docs here. And so these are essentially the API docs for Pulumi resources.
So another great question from Christian asking, how do you do the Kubernetes updates in a CI/CD pipeline? Now, I'm not sure whether they're referring to the cluster, like the EKS cluster, or the Kubernetes resources. But I guess there's kind of the same question. They're kind of the same thing anyway. So how would you do this in a CI/CD pipeline?
That's a great question. So So you have so CI/CD is pretty straightforward. It's kind of standard across all IAC tools, but here's what I'd recommend that you do with Pulumi, right? So if you're going to have your, assuming that you're doing standard push-based CI/CD as opposed to GitOps. If you're doing GitOps, use the Pulumi Kubernetes operator. All of your drift will be automatically resolved. That is potentially a good solution for your workloads. I would absolutely not recommend using a GitOps workflow, by the way, for your like infrastructure, because sometimes drift happens and it needs to happen, particularly around things like networking. It's, sometimes when you have like network issues, you got to go into the console and like tweak some settings and just experiment. And you might not have the time if you're in the middle of a critical issue to resolve all that stuff through an IAC pipeline because of the delay involved. Yes, you do need to go back and resolve that drift eventually. But yeah, sorry. So that's my little spiel on not using GitOps for like core infrastructure. If you're going to use GitOps, use it for stuff that you create with the Kubernetes operator, with the Kubernetes provider. Okay,
basically the stateless stuff, yes. Not the databases and all that kind of thing, no. And what Josh means by GitOps is like Flux CD reconciliation stuff. That GitOps as push to main in general is a whole other story, and that's an argument over beers later on.
And specifically with the continuous resolution of drift. Okay, so for most of your infrastructure, here's the pattern I would use. When you open a branch, open a PR, it's going to have a trigger that's going to run Pulumi Preview. Pulumi Preview will show you what it intends to do. Now, because infrastructure as code is stateful, you need to see two things in order to give a good pull request review. You need to see both the code and the changes that code will make in your infrastructure. You might just be looking at the code, and you might not notice that, for example, those changes might recreate your production database, which is probably not what you want if you want to stay in business. So, you got to be very, very careful about that. When your review looks good, you've looked at the code changes, you've looked at the infrastructure changes, you merge that to your main branch. That's when you're going to run Pulumi update, which is going to deploy those resources into whatever the environment or environments. You can do things as continuous deployment if you like. You can also, if you want to, keep long running branches. The thing that we do at Pulumi for Pulumi Cloud itself is that we have feature branches. Those will you can actually spin up temporary environments using Pulumi deployments. Pierce, what's the name of that feature again? They're
preview environments.
Yeah, preview environments.
Preview stacks.
Like preview stacks, yes. So you can actually spin up a temporary environment of that entire stack if you want to. And that will only exist for the life of the pull request. And then once everything looks good, you can merge it to main. That's going to run Pulumi update. And in addition to that, you probably also want to run some sort of drift detection on a schedule every day, every other day, something like that. And you can run the Pulumi preview command, except you can pass it a flag to say, expect no changes. And when it comes to CI/CD, by the way, we have a bunch of integrations. We have a GitHub action that is very, very popular. You can use Pulumi deployments within Pulumi Cloud itself if you want to keep it all there. And then we also integrate with GitLab as well. And essentially, because Pulumi is just a CLI program, you're going to be able to use Pulumi with any CI/CD system because they pretty much all allow you to run shell commands, and that's essentially all you're doing when it comes down to it. So that answers that question about CI/CD, hopefully.
And can you go into drift detection? How would you do drift detection, and when do I need to use the -- refresh, and why?
So you would not want to refresh there's a Pulumi refresh command. What that will do is it will take your state file and refresh the state of everything in your state file. So if you change the route table on a VPC, it would detect that change happened. Refresh does not run by default during a Pulumi operation. That is an intentional design decision to aid performance. And so you would run Pulumi refresh with expect no changes. Or I'm sorry, maybe it's preview. I might have that wrong, actually. It might be preview.
What was that last bit? Sorry.
I can't remember if it's Pulumi Preview or Pulumi Refresh. I believe it's it actually might be Pulumi Preview. Let's see.
So while he's looking at that, Nathan, drift detection you can use just using the CLI, but via Pulumi deployments, yes, it's enterprise and business critical. Coming to Teams as well.
Sorry, I gave the wrong subcommand. It is actually, you would actually run Pulumi Preview with expect no changes, not Pulumi Refresh. Sorry, I misspoke there. So if you run Pulumi Preview, right, what that's going to do, it's going to say like, hey, like, what do I need to do in order to, yeah, there should be no changes, because if there are changes, then there's drift, because you haven't changed the code. So we have one question. I'm going to close with this question, which is the orange headstock on that P base. That is one of the bases behind me. It's that one on that side. Looks great. Are you in a band, and what is the name of that band? So thank you very much. It is Fiesta Red is the official name of the color. And that is a modern vintage precision bass. And I am at present not in a band and looking to join a project. So you will be able to find me. My email is coming up on the next slide or two. But first, before we get to my email address, I would like you to continue your Pulumi journey, and so would peers as well. And there's 3 ways that you can do that. First, please hop over to the Pulumi community Slack. You can join that at slack.pulumi.com. There is a Kubernetes channel in there. I am in there. If you end up running this demo code, give us some feedback. We would love to hear what your experience is like. That'd be really, really helpful. If you have questions, there is a huge community of both Pulumi employees and devout Pulumi community members who will be happy to help you. Second, if you do not have a Pulumi Cloud account yet, please sign up for one. It is free individual use forever. If you have used Pulumi Cloud for a while and are thinking about adopting it on an organizational basis, you can create an organization that will trigger a 2-week free trial of our full suite of features. It's like the highest level, our business critical level. And so you can try out everything that Pulumi Cloud can do. That includes SSO, SCIM, all of our most advanced features for policy enforcement. And that is, we don't ask you for any payment for that, by the way. So you just get it. We just turn it on for you for 2 weeks free. Try it out, see if you like it. And then finally, please give the demo code a try. Give the, try out the experience of writing Pulumi programs for Kubernetes yourself, and give that ESC demo a try as well, and see how Pulumi can make your life easier as a Kubernetes administrator. So here's my aforementioned email. On behalf of myself and peers, I would like to thank you all so much for choosing to spend your time with us. And we hope you have a lovely rest of your day. Feel free to reach out to me via email if there's anything I can do to help you with your Pulumi journey. And my email address, again, is josh@pulumi.com. Thanks so much, everybody. Have a lovely rest.